Regression equations are often useful for predicting the value of one variable given some specific value of the other variable. When making predictions, we should consider the following. Use the regression equation for predictions only if the graph of the regression line on the scatter plot confirms that the regression line fits the points reasonably well. Use the regression equation for predictions only if the linear correlation coefficient R indicates that there is a linear correlation between the two variables. Use the regression line for predictions only if the data do not go much beyond the scope of the sample data. So you don't want to use values much beyond your highest value in your sample data or your lowest value in your sample data, because you really don't know what's going on those extreme ends. You don't know if the linear correlation continues. If the regression equation does not appear to be useful for making predictions, the best predicted value of a variable is its point estimate, which is the sample mean. So if we find that there is no linear correlation, we won't be able to use the equation for our predictions. And so if we're asked, well, what's the best predicted value for y given that x is some number, then we just say, well, the best I can tell you is the average y, the mean of our sample. So our strategy for predicting our values of y will begin with the question, is the regression line a good model? So we need to know if it is, because if our answer to that is yes, then we'll use the equation and we'll substitute that given value of x in the regression equation to calculate our predicted value of y. So if it's a good model, we use the equation. But if we determine that there is no linear correlation, and so we say no, the regression line's not a good model, regardless of the value of x, it doesn't matter what x we're asked to consider, the best predicted value of y is y bar, the mean of the y values. And we can get that on our calculator using the descriptive statistics for the y data.